Hello viewers, welcome to GIRI classes. In this video lecture, we are going to discuss eigenvalue equation. This is the second video lecture regarding your IIT GATE chemistry previous year question paper. So let's get started. So you have operator minus h cut square d square by dx square operates on a function e to the power minus I kx. What will be the result? These are four options, right? So what you will do, that means minus h cut square d square by dx square, which is double differentiation with e to the power minus I kx. Okay, you already have this formula, right? D by dx e to the power ax, the value obtained was a e to the power ax. Similarly, d by dx e to the minus ax is equal to minus a to the power minus ax. Similarly, for e to the power minus ikx, before that you have to keep it in mind, this is double differentiation. That means you will have differentiation of e to the power minus ikx with respect to x for the first time, and the result will be once more time it will be undergo derivation with respect to x. Okay, so what was that result? The result was minus ik into e to the power minus ikx. Okay, so it was like this, minus a e to the power minus ax, right? So you have to remember one thing, this k is certainly a constant quantity, and I already we discussed this one. This is a constant quantity, it can be variable. It's an imaginary value, but it is not a variable value. That means my root over minus 1 cannot be root over minus 2. That means it's a constant quantity. Okay, so what you will do now, you keep this constant outside of this derivation, because you know that very well, derivation always operates with the function, okay, or the variables, not with the constant quantity. So that is minus h cut square into minus ik and derivative of e to the power minus ikx with respect to x. Okay, so now coming to the next point, that is minus h cut square into minus ik, that is d by dx e to the power minus ikx. Okay, now what happened here? Here the derivative will be again minus ik e to the power minus ikx, right? So what was your result? Now you will have result like this, I h cut square in k, that is this one, this is negative plus, negative into negative is plus, that is I h cut square k, and multiply with minus ik, that is minus I square h cut square is k square, right? You already know that I is equal to root over minus 1, I square is equal to minus 1, and minus of I square is equal to minus of minus 1, that is plus 1. So that means this is 1 into h cut square k square e to the power minus ikx. Okay, and you can represent like this also if you want to prove how this result came, that is I is equal to root over minus 1, and this one I square is equal to root over minus 1 square, that is, you know that root over, that means this is to the power half, right? This is to the power half, this is square root, right? This is square root, not cube root, that is will be cube will be 1 to the power 1 by 3. Okay, so that is minus 1 to the power 1 by 2, and this is square was already there, that is 1 by 2 1 by 2, so 2 to cancel, that is minus 1, that is minus I square will be minus of minus 1, that is 1, I square is equal to minus 1. Got this point? Now the fact was when you operate suppose this is my function, suppose this is my operator a, this function psi 1. So what was the result? You got the common function, that is psi 1, and therefore this psi 1 is known as Eigen function, and this value is known as Eigen value, right? So what was the result? The result was this one, h cut square k square e to the power minus ikx, h cut square k square e to the power minus ikx. The result is option A. Okay, so next coming to the point, d square by dx square minus 16xx square operated on a function e to the power minus 2x square. e to the power minus 2x square. Okay, so there is two methods to do it, that is double differentiation of e to the power minus 2x square. We can do it shortcut way or we can do it as usual method, but we suggest you, personally I suggest you use the shortcut method because examination we don't have much time. Okay, so now coming to the opening of this bracket, that is d square by dx square minus 16x square with e to the power minus 2x square. Okay, that is d square by dx square with e to the power minus 2x square minus 16x square e to the power minus 2x square. That means you will have double differentiation of this factor which can be represented like this, d by dx e to the power minus 2x square. Okay, now what will be the result of this value? See this one, already I told you d by dx e to the power minus ax is minus e to the power minus ax. So it was the shortcut formula, but actually here the rule is chain rule. What was the chain rule? You will apply like this, that is, suppose you think this is your z, that means d by dx, that is d by dx e to the power minus z, that means it can be represented like d by dx e to the power minus z into d by dx z into d by dx z, right? So if this is your z, then you can represent like this, d by dx e to the power minus z into d by dx z. Okay, so whenever you have typical your variables, you have like this, suppose this is your function, another function is here also, or variables here also, then you apply always chain rule, and you know that derivative of e to the power minus x will be minus of e to the power minus x. So that means e to the power minus z, derivative of e to the power minus z with respect to x will be minus of e to the minus z, and this is dz by dx, that will be minus e to the power minus z d by dx 2x square. This is constant never undergo in differentiation or integration, so you put this constant outside of this differentiation. So what you got e to the power minus 2x square minus of e to the power minus 2x square into 2 into d by dx x square, and you already know the derivative of x to the power n with respect to x will be n of x by n minus 1. Similarly, derivative of x square will be 2 into x to the power 2 minus 1, that will be 2x. So what was the result? That is your 2x into 2 into the power minus 2x square minus of e to the power minus of e to the power minus 2x square, right? So what was your result? That is minus 4x e to the power minus 2x square. Okay, so when you practice more, you will easily evaluate your answer, that is e to the power minus 2x square, that is minus of e to the power minus 2x square, and derivative of 2x square will be 4x. Okay, so that is minus 4x e to the power minus 2x square. Okay, try to approach this method, don't go by this method. Okay, after that we will have a shortcut method. So double differentiation of e to the power minus 2x square. So first differentiation of e to the power minus 2x square with respect to x was minus 4x e to the power minus 2x square. Now we will have differentiation of minus 4x e to the power minus 2x square. Okay, see, derivative of minus 4x e to the power minus 2x square. Okay, so minus 4 is your constant, put constant outside of this differentiation, that is minus 4 d by dx x e to the power minus 2x square. You have two functions, that is u and v, and already you know that if this is your first function and if this is your second function, so what you do, derivative of your second function keeping outside the first function and derivative of first function keeping outside the second function. So that is u dv by dx and v dv by dx. Similarly, you can do like this, u dv by dx and v du by dx. Okay, that is d by dx e to the power minus 2x square and already we discussed minus 4x e to the power minus 2x square, that is x into minus 4x e to the power minus 2x square, that is e to the power minus 2x square, and derivative of x with respect to x will be 1. Okay, so what was the result? The result was like this, that is minus 4 minus 4, that is 16, this x into x, that is x square e to the power minus 2x square, and this one, that is minus 4 e to the power minus 2x square. So finally what you got, that means del d square by dx square e to the power minus 2x square, the result will be 16x square e to the power minus 2x square minus 4 e to the power minus 2x square, right? And you can repeat it like this, d by dx e to the power minus 2x square. So what was the result? That is d by dx minus 4x e to the power minus 2x square. What was the result? Finally this one, 16x square e to the minus 2x square minus 4 e to the power minus 2x square. Okay, but in your examination you don't have much time, so you will apply this shortcut method, that means derivative of double derivative of e to the power minus ax square. Okay, so think this is your a, that is your 2, so what will be the result? That is 4a square x square minus 2a, 4a square x square minus 2a e to the power minus ax square, right? This is your common function. Okay, so 4a square x square minus 2a, okay, that means 2x ax whole square minus 2a, very easy to remember. Okay, just practice it. That is 4 into, here a is equal to 2, 4 into 2, right? So this one 4 into 2 square and into x square. Okay, so see this one, 4 into 2 square into x square into the power minus 2x square minus 2 into 2 e to the power minus 2x square, that will be 16x square e to the power minus 2x square minus 4 e to the power minus 2x square. So the result will be like this. And what was that answer? The answer was minus 16x square e to the power minus 2x square minus 4 e to the minus 2x square. The result was for d square by dx square e to the minus 2x square, but we found out this value. But what was actually there in your question? The question was like this, this was your operator and it was operated on this function. So that means you opened it and you got the result. That means you already found out this result, and now you will have this result, that means which will be subtracted. That means this value will be subtracted, this value will be subtracted. So what was the result? That is 16x square e to the minus 2x square minus 4 e to the minus 2x square minus 16x square e to the minus 2x square. This is plus, this is negative. So whenever you are doing this, calculating this, just be careful. That is minus 4 e to the minus 2x square minus 4 e to the power minus 2x square. That means, suppose this is your operator a and this is your whole function psi 1. What was your result? That is a psi 1. That is same, that is common Eigen function. That is common function which is represented as Eigen function. And what is that constant? The constant was, therefore corresponding constant was known as Eigen value, and the whole equation is known as Eigen value equation. Already we discussed in previous lecture. So the Eigen value was minus 4. What was the answer? Option B. Option B. Okay, that was option. The answer was option B. You can directly find out from this one, that is 4a square x square e to the power minus ax square minus 2a to the power minus ax square. That is 4 into 2 square x square e to the power minus 2x square minus 2 into 2 e to the power minus 2x square. That was 16x square e to the minus 2x square minus 4 e to the minus 2x square, right? And this one minus 16x square e to the power minus 2x square. Okay, so cancel this one. What was your result? Minus 4 e to the power minus 2x square. Okay, so this one minus 4, this was operator a, this one psi 1, this one a psi 1, right? So you have only 1 2 3 4 5 6 steps only, so don't go for this lengthy steps, just to understand this one. So answer was option B. Okay. I hope you enjoyed this video. So like, share and subscribe GIRI classes, and thank you very much for watching GIRI classes and giving your valuable time. Thank you very much.